Hugely important skill this. We're going to be writing a quadratic, could be 3 or 2 terms. The one I'm going to show you is 3 terms. We're going to be writing this in completed square form. Okay. Now, why would we be doing this? Oh, this form is just the best. This is just, of all the forms of a quadratic, you've got expanded form, factorised form, completed square form. This one is the best. Usually, the most common reason is because we want to think about the graph, and this shows us how the graphs move left and right and how the graphs moved up and down. So a main reason for doing this is to do with graph sketching. Shows us where the vertex is of the quadratic. The quadratic looks like this and it moves around and it shows us where the vertex is. Another really common reason for using this is going to come in the second year, not the first year of the course, but it's to find the inverse of a quadratic function. We'd complete the square and then rearrange it and we'd find the inverse. In a similar way, or in fact, indeed the same way, you can use this form to solve the equation. To solve a quadratic equation, you could factorise or you could complete the square. And if you complete the square, you could move the c to the other side and then you could divide by a and then you could square root and then you could subtract the b. So it's a good way of solving a quadratic. And the other reason why it's really good is that you might be able to use it to prove that a quadratic is always positive, because something squared is always positive. If c is positive and a is positive, then I'm taking a positive number, timesing it by a positive number, and then adding on a positive number, so it's always positive. So this is a useful form to put a quadratic in to show that the quadratic is always positive and never goes negative. So how do we do it? Step 1, you just use the formula, and the formula essentially what you need to do is to get this b here and divide it by 2, and it goes in 2 places. It goes there and there in 2 places, half of the b. This is always a minus, and that's a common mistake that students make. So even if it's x squared minus bx plus c, then that would be x minus half a b squared. So this minus, this plus would change, but this one never changes. This is always a subtract here, like that. So that's a very common mistake students make, is to not get that minus there. Okay, so if we've done that, we're going to tidy up the half b squared. So just sort out that number, sort out what it is, and then thirdly, combining those 2 terms on the end to make one number. Warning, warning. In fact, I'm going to colour in my little cone of warning here to emphasise it, because this is very, very common. Numbers go wrong. Don't try to do this in your head, particularly with this minus, and this might be a minus. Just beware numbers, use a calculator. Why not? Okay, so that's basically it. That's how we complete the square, formula, tidy up, combine those. What about if the coefficient of x squared, the a, like here it's a 4, isn't just a 1? Well, we basically need to move this 4 out of the way. So what we're going to do, I'm going to call this step 4, is to write it as y equals. So that's how we're going to start this. We're going to write it as y equals 4x squared plus 3x minus 1. Even though in the actual question this is just an expression, I've made it into an equation. And that's using this step here, step 4. And the reason I've done that is because the next step is to divide all the terms by that a, by that problem. So we're going to divide the y by 4. We're going to divide this by 4. We're going to divide this by 4. And we're going to divide this by 4. Everything gets divided by 4. Okay. So first step, write y equals. And that's so that we've got a left-hand side for that quarter to go on. Then the next step, divide it all terms by 4. This is using step 5. He gets divided by 4. He gets divided by 4. He gets divided by 4. And he gets divided by 4. Okay, next step is to complete the square. So that's this bit here. So we go back up here now that we've just got a normal quadratic with a 1 at the front, and we're going to complete the square. So we get a bracket, x plus, then we halve the fraction. Now, halving a fraction means doubling the bottom. So that's that bit, and then squared, and then a minus, and then half of b, same number, squared, and then the c goes on the end. So this is the completing the square. And the main thing to remember with that completed square is that this thing here is going to get halved. And it goes the same one there, and this is always a minus. So this is step 1. Okay, now we're going to tidy up that half b squared, this thing here. Everything else can stay the same. So on the top, 9, on the bottom, 64. Okay, that's that bit tidied up. Just basically I'm squaring it. Now combining that bit and the c, so combining these two terms here into one term, and I'm going to use a calculator for that because otherwise it might go wrong. So we've got minus 9 over 64 minus a quarter is minus 25 over 64. So that step there just pulls that minus a half b squared and the c together to make one term. And then we can do this final step here. Final step times all the terms by the a. The a was the problem at the beginning, the 4, which we kind of like got rid of the problem. Ignore, ignore, ignore. And now like, fair enough, we'll put that back. So this is going to get times by 4. And this is going to get times by 4. So that's multiply all terms by 4. And did I miss any steps? So what did we do? Wrote it as y equals, divide all the terms by 4, complete the square on the right-hand side. We did tidying up or expanding, or whatever you want to call it, sorting out the half b squared. Then next step, combining those terms to make one term here. And then finally multiplying everything by the 4 to get the answer. So how are we going to check this? Same way that we always check the rearranging of an expression. We are going to take an x and put it in here, and then take the same x and put it in here and see if it comes out the same. Because if this is the same as this, then it will come out the same. For some reason that I don't know, I always use 2.5. You can use whatever number you like. I mean, I wouldn't use 1 or 0 because they do funny things like 1 squared is 1, which is not what most numbers do when they are being squared. They don't normally stay the same. So I would just use something like, I don't know, anything. Right, 63 over 2 is what I'm hoping for down here. 63 over 2. 4 lots of 2.5, add 3/8 squared, minus 25 over 16. Oops, no, that's not what I meant to do. Minus 25 divided by 16. Yay! 63 over 2. So they're both 63 over 2, which means that this is identical to this, which means I didn't go wrong and I did it right. But I didn't write in what I'd done from here to here. I did step 7. Very last thing is to point out the most common mistake. And the most common mistake is to make sure that you divide all of it by 4 and times all of it by 4 at the end there. Oh, well, divided by a, whatever the a is.